The next step is to add tables into our database. Table is a database object that is a structured version of the data that we want to store. So we can think of tables like we think of classes in C#, in so much that a table represents some entity, and a table typically will have a series of attributes called columns that are, again, attributes or properties of that given entity. And we'll talk about relational database management systems and relational theory in a different course. I don't want to spend too much time, but we can't get very far without at least creating a table with columns. So we will start off by creating actually a first table and add additional related tables in upcoming lessons in this course. We're going to start off with an author table, and then later on we'll create a publisher table and a books table. And so this database could potentially be used to store information about books that are for sale on our company's website. We want to store the author information and the publisher information as well, so that not only can we display it to the end user, but then we can also look up by author and find out all the books that a given author has created, all of the publishers that a given author has authored books for, and so on. So we'll start off by creating an author table. We want to expand the first database object in the Object Explorer, and then right-click on Tables and select the Table option. And here we see a designer with 3 columns. We can create a name for our column, for a given column, give it a data type, which we'll talk about in a moment, and then whether or not that column should allow null values or not. All right, so let's start off. I would probably start off by creating an author ID, but I don't want to talk about the concept of an ID just yet. We'll talk about that 2 lessons from now. I want to start off by just something obvious, creating a name for the author. Now I could split this up into first name and last name as 2 different columns, depending on how I plan to utilize the data. But in this simple case, we're just going to call this name, the name column representing a first, middle, last name, surname, whatever terminology you want to use inside your organization. Now I have to say what data I expect to save into this column, and not only the type of data, whether it's numeric, it represents a date, or represents string values, but then also the degree of precision that we want to retain for that given column. So you'll spend a lot of time learning about data types and their propensities. We want to choose a data type that best represents the kind of information we hope to save and retrieve from the database. So again, we're going to talk about types in the very next lesson, but one tool that will help SQL Server preserve and protect the integrity of our data is to choose the correct data type for the data that we're going to need, and as well as the precision of that data. So in this case, I want to choose nvarchar 50, and let me explain why at a very high level, and then we'll come back to this notion again throughout this course. So let's start with the letter N. The N represents a national code, I think is the name. I'll have that definition for you next time. But essentially, it indicates that we want to allow Unicode characters to be saved. So not just your typical ASCII characters, the 128 uppercase, lowercase, and punctuation set that are used typically in an English setting, but then also other character sets like Arabic or Kanji, anything that doesn't look like your typical or the English character set. Okay, so the N represents the fact that we want to enable Unicode characters to be saved, which nowadays, if you're going to create any kind of application that's going to be used outside of the United States or Canada or the UK, you definitely want to use the N version of these data types. Var means variable in size. So as far as precision is concerned, we're going to say variable in size up to 50 characters. Now we could say instead of nvarchar, we could just say nchar. Let's see if I can find it real quick here. And nchar 50. And what that'll say is you should always allocate exactly 50 characters of space per row for this column of data. Nvarchar says, tell you what, you can use a variable amount up to 50, and then if if you use less, then it won't take up quite as much room in the database. So my next recommendation is nvarchar, if I can get back to it here. Nvarchar 50. 50 means up to 50 characters, no more. Okay. And then, are we going to allow nulls? Can an author not have a name? No. We're going to force SQL Server to, or tell SQL Server to enforce the fact that the name column always needs data. All right. So that was just a brief explanation of our first column. There are other properties of the column that we can set, and you'll see how this comes into play a little bit later. But for now, let's move on and create a second column called biography. And so here we might store a couple of paragraphs worth of data about this given author. And here we're going to say we want to store varchar max or varchar max. And the only thing different, as you can see, is the fact that I'm using the term max for the maximum allowable space. This will allow me to save paragraphs or pages of information about the bio, about this particular author. Now, in reality, that may not make sense. I might want to limit this to 255 characters, 1,000 characters, or some other size. But since we're just getting started, this will not restrict the amount of characters that we can store inside of this field. The next, I might want to store the date that we added this author to our database. And so I might choose a date time. Now, the thing about date time, there's several different date time options here, or just date. The challenge here is that these have a high degree of precision, and I might want to use a different data type like small date time instead, which should use, it doesn't retain information down to the millisecond. It'll just retain down to, I believe, the minute or the second. And so small date time might make better sense for us in this case and in most cases, honestly. Now, I don't want to allow a null here, but I might allow a biography column to have a null value, meaning it won't have any data inside of that given column. And then finally, I want to create an active flag, whether this author is still active in our system, or are we not going to display this author's information, or for some reason not work with this author again. So I might want to retain the author so I don't create a duplicate author in the future, but I might want to just say, is it currently active or not? And so I'll use the bit, which is like a Boolean value, yes or no, 0 or 1. And 1 would be active, 0 would be not active. And again, we're not going to allow a null. In fact, I tell you what we're going to do. We're going to set the default value in the column properties to the number 1. All right, and so you can see that when I click off of the default value or binding for 1, it kind of puts a parentheses, which means it's a literal value of 1. So I wouldn't even have to specify this whenever inserting new rows in the database. I can just rely on the fallback default value and ensure that it will always be active as we first insert the record in the database, or we can update that record and change it otherwise. Okay, so you might be wondering why couldn't we use the nvarchar max instead of nvarchar 50 here? I mean, why wouldn't we just allow the longest possible name instead of restricting it to 50 characters? Again, I think this has to do with data integrity. I don't want some artificial constraint at this point in the biography, because it could be a long biography and I want to feature that. But in the name, I don't know of too many names that go beyond 50 characters, and so I don't want some end user typing in, thousands of characters and trying to find some loophole or some workaround inside of my database. So generally speaking, restrictions are important when it comes to data types. Constraints are important because it limits the possible values and improves the overall data integrity. However, there are cases where it doesn't make sense to have an artificial constraint. Again, in this case, nvarchar max, so I might want to differentiate those two precisions here with two different versions of the same data type for those two columns. All right, so before we move on and actually commit this table, what I want to do is actually talk about data types briefly in the next lesson, just to give you a high-level conceptual overview of data types and which ones are available. And then we'll come back in the lesson after that, finish up working with this table, and we're going to add and talk about rows and how to uniquely identify rows by adding a key and a primary key constraint to our table. All right, so again, stick around, not the next lesson, but the one after that, we'll finish up this table. We'll see you there. Thanks.